Start with just a quick review of everything you guys can remember that we talked about yesterday.
Probability.
Compound probability.
So we talked about probability. Let's focus there for a second. So let's start with simple probability. What is probability? Like, what is it?
The likeliness of something.
The likeliness of some event occurring. There you go. How can we write probability? How can we represent it? We can write it as a fraction, a decimal, or a percent. All right, when we write it as a fraction, this is the way we normally start with it. What's the number in the denominator represent?
The amount of different possibilities.
That's all the possible outcomes. And what's the number in the numerator represent?
One of the
Favorable outcome.
The number of favorable outcomes. The amount of times I can get the thing that I'm looking for. All right, these are all for simple events. Then we talked about compound events. So compound event was when two or more things were happening at the same time. We could be flipping a coin and rolling a die. We could be flipping the coin twice, rolling two die. Okay, so that was compound probability. Does anybody remember anything else we talked about? I heard y'all say both of those.
I remember another one, but
We talked about the difference between theoretical probability and experimental probability. What's the difference? Does anyone remember?
experimental's like experimental. If
You
I can
doing it, and then the theoretical is the math portion of it.
Correct. So experimental probability, you actually have to carry out the experiment. If I say I'm going to flip a coin and roll a die, then I have to do that. Or someone has to have done that. And then we record the results. With theoretical probability, you don't actually have to perform it. We're just thinking about how many possible outcomes there are and how many of them are favorable. And then does anybody remember at the very end of the lesson, the last thing we talked about, where I used the beads. Did I do that in this class? 5 white beads, 5 red beads.
Yeah.
What happened there?
You took one out, and then
You took one out and then took it out completely, and then what was the percentage of you getting another white bead?
Correct. So that time I drew a bead and drew another bead. So it was a compound event. But the second time I did not put the first bead back in. It was without replacement. Does anybody remember what that was called? Those are dependent events, where what happened the second time in the second event depended on what I drew the first time. So that's kind of a brief review of everything we talked about yesterday. I wanted to say it all again so maybe you could remember parts of that. One thing we didn't bring up that I need to talk about now is we talked about probability is the likeliness of something to occur. What is the lowest possible probability we could get? It's not a half. 0. If something's not going to happen, then we could use the decimal number 0, or it has a 0% chance.
Like you rolling a 12 and a 6.
Excuse me, teachers. Seniors that went to Texaco first period this morning, you need to go to the high school library at this time. Seniors, if you went to Texaco first thing this morning, you need to go to the high school library at this time. Thank you.
Okay, so this is the smallest number that can occur with a probability. What is the highest, if something is certain to happen, the highest possibility? That is a 100% probability. How would we write that as a decimal? What's 100% as a decimal number? It's just 1. Right? 100% is 1 as a decimal. So all of our probabilities, like here was a probability of 0.25, all of our probabilities have to be between 0 and 1. 0 means it can't happen. 1 means it's going to happen. It has to happen. And any number in between it is the likelihood of something occurring. So if, for instance, if the answer was 0.9, is that likely to occur or not likely to occur? It's likely, right? That's 90% chance of happening. Whereas if I had 0.25,
That's
Is
less
that-
likely.
that would be considered unlikely, right? Anything under 50% is less likely to happen, is less likely to not. Let me say it again. Anything under 50%, 0.25, is more likely to not occur than it is to occur.
Good job.
Anything under 50%. What I need you to do now is I need you to get with a partner. You and a partner. Here's what I want you to do. You're going to look at your partner. I want you to decide if your partner is a yes or no for the taco tongue and a yes or no for the evil eyebrow. So you need to know, can you do the taco tongue? Can you do the evil eyebrow? We're going to collect the data and put it on a table on the board. Let's clean up this data because we just recorded it with tally marks, and let's put in a number answer for all of these. So the one that's going to be easiest is right here. We had no one that could do the evil eyebrow and not do the taco tongue. So in that column, we're going to put a 0. I'm sorry, this is boring. Here, in the third one,
I'm sorry.
we've got 3 people that could not do the evil eyebrow and could not do the taco tongue. So we're going to put a 3 in that box. Here was 2. That's for people who can do the taco tongue but can't do the evil eyebrow. And then we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 people that could do both. Okay, so in that box we're going to put a 12. So again, what we've done here is called a two-way table that we've just created. Now you can see on yours, and it looks like I didn't take a picture of it on mine. It has a place down here where it says total. And it has a place up here where it says total. Okay, so what we're going to do, when we total, look at this row. What does this row represent?
Taco tongue.
This is everyone who can do the taco tongue. So how many can do the taco tongue? 14 can do the taco tongue. Right? This whole row was yes to the taco tongue. This whole row is the number that cannot do the taco tongue. So there would be 3 in that one. For a total of 17 students. Right? So these should all total up the same. Now when we look here, how many could do the evil eyebrow? 12 could do the evil eyebrow. How many cannot do the evil eyebrow? 5. For a total of 17 again, right? This total is the same in both columns. So we have created this two-way table.
And then we do probability.
Okay? So now what I want you to do, have you guys done a Venn diagram before?
A little bit.
So I want to see if you can fill out that Venn diagram. You can be with a partner. I'm going to give you a minute to see if you can figure out what the correct values are there. Okay, so I'm hearing some people that are a little confused. I'm going to give a little bit of an overview of how a Venn diagram works if you are unfamiliar with that. So I've got 2 circles. Those represent a sample space. Everybody that's in this circle can do the taco tongue. Everyone that's in this circle can do the evil eyebrow. Now, what does this overlap represent? Those are the people that fit into both circles. These will be the people that could, yes, they can do the evil eyebrow, and yes, they can do the taco tongue. So if I'm in this one, I'm yes on evil eyebrow, but I'm not yes on taco tongue. Right? And then here, these are people that are yes on taco tongue, but they are not yes for evil eyebrow. Right? That's this column. And then what does this represent? This box would be everybody else that's in the universe, is what it's called, but they don't fit into these circles. So these would be people that can't do either one of those. That would be this box. Right? You're in the universe.
You got another hand.
So if it were me, I would start here. I would start with the overlap. How many are in the overlap? There are 12 in the overlap. There are 12 that could do both. How many could do taco tongue, but they couldn't do the evil eyebrow? There's 2. Because see, look, how many's in this circle now? In this circle is 14, which represents everybody that could do the taco tongue. 12 of them are in this part of the circle, 2 are in this part of the circle. Now here, how many would be here? They can do the evil eyebrow, but they don't fit into the taco tongue. So how many could do the evil eyebrow, but not do the taco tongue?
0.
Nobody. So I have nobody in this sample space. And then how many people couldn't do either one?
3.
3. Knowing what you we went over yesterday, see if you can answer these 2. Can you tell me the probability that a student selected at random can do the taco tongue? And then what notation would we use to write it? So remember how yesterday I showed you the correct way to write the probability of some event occurring? You need to write it out like that. And then you don't know 3 yet. We'll talk about 3 after you guys get 2.
Oh, no.
I say you don't know 3. I'll give you a chance to see if you can do 3, but I did not go over 3 with you guys yesterday.
Should be 8.
So here, let's first talk about the notation. What is the probability a student selected at random can taco tongue? So what's our notation going to look like? It would be the probability, that's the capital P, the probability of what event occurring? Taco tongue. Yeah, something happened on my pen. I got it fixed now. It'll be back to normal now. The probability of taco tongue. So what's the number on bottom represent? How many total possible outcomes are there? So if I picked one of you at random, how many choices do I have? 17. That's why I want to know what's the probability that the person I choose can taco tongue. So everybody I'm choosing from, there's 17 people. That's the total possible outcomes. And how many of them are favorable? That means they can taco tongue. 14 can taco tongue. Is there any questions on 2? Do you understand this logic now? Maybe?
When you said something like universe, like in that universe, what does that mean?
The universe is just everybody that's in your population. Everybody that could be chosen.
17 people.
Could be selected. In this case, we're just looking at this class. So my universe would be 17 people.
Okay, so that's always just going to be the total amount of people in the situation.
Correct. 3, what is the complement? So that's a word we didn't talk about yesterday. Does anybody know what the complement means?
Saying something nice to somebody.
That's the wrong kind of compliment.
Is it?
What match is it?
You look good today, too.
What match?
What do you mean by that? Goes together.
Yeah.
If someone's your complement, right, they can do things you're not good at.
So like the opposite.
Kind of. So when we talk about complement here with probability, the complement is it is the opposite of what the event is we're looking for. So, for instance, if I was flipping a coin and I want to know the probability of getting heads, that would be 1 out of 2. Well, the complement is everything else that doesn't give me heads. Right? So in that case, it would only be tails. So let me go back and talk about those very quickly. So if I wanted the probability of getting heads, that would be 1 out of 2. But now the probability of getting heads, the complement of that, that would be everything else that could happen. So there's still only two possibilities. How many of them are not heads? 1 out of 2. So the complement would be also 1 out of 2. Let's go to one that's more interesting. Let me roll a die. If I wanted the probability of getting the number 4 when I roll a die, what's the probability? What's the probability that I roll a 4? And then what's the probability that I get the complement of rolling a 4? So this would be everything else that's not rolling a 4. Would be 1, 2, 3, 5, or 6. That's the complement.
Oh, yeah, we talked about this yesterday, I think.
We didn't.
Oh, well, maybe.
We talked about it last year with,
So we might have last year.
yeah.
It says here, what is the complement of the probability that a student selected at random can taco tongue? So if I'm looking at, we're going to write it in the correct notation, the probability of the complement of taco tongue. That means out of the 17 people that are still in the universe, what's the complement to the ones that can't taco tongue? Or in other words, what's the ones that can't taco tongue? 3 out of 17. Because sometimes it's harder to think about it with a not. And you'll see we're going to have some more complicated questions later in this one where it's harder to think about it with the word not instead of complement. Another way, here's kind of the trick to help you with complement sometimes. If I don't know what the complement is, it might be easier to find out what the original was, and the complement is always 1 minus the probability of that event occurring. Complement. There we go. So on some of them, that may be the easier way to see it. Not yet? These? Let's start with the first one. If I choose a student randomly from the class, what's the probability that they say yes, they can do the evil eyebrow? Yes for the evil eyebrow was 12 out of 17. Remember, the people that say yes to the evil eyebrow are here in this column.
Oh, I just looked at it wrong.
Right, you were looking at the yes for the taco tongue. Is that what you did? Or did you use the Venn diagram?
Venn diagram, that's what I used.
So if I'm looking at the Venn diagram, how many numbers are inside of evil eyebrow? Look inside the circle, evil eyebrow. 0 and 12. Right, because 12 is in the middle, it's in both. So that means there are 12 that are inside evil eyebrow. Any questions on this one? What's the probability the person I choose at random said yes to taco tongue and yes to evil eyebrow? Yes to taco tongue and evil eyebrow, that's this portion, or it's the center of your Venn diagram. It would also be 12 out of 17 for us. What's the probability the person I choose at random can taco tongue and not do the evil eyebrow? So I'm looking for the ones that say yes to taco tongue and no to evil eyebrow. There's only 2 that fit that criteria. So it would be 2 out of 17 there. Any questions on any of those 3? Sound like we're doing okay. All right, look at this one. What's the complement? See the C? The complement to the people who said yes, they could do the evil eyebrow. So if 12 out of 17 said yes to the evil eyebrow, then the complement of that would be 5 out of 17. It would be the other 5 people. Another way you could look at it, look at the ones that said no to evil eyebrow, right? There's 5 of them there. What's the probability the person chosen at random says yes to the evil eyebrow and no to the taco tongue?
0.
Yes to evil eyebrow, no to the taco tongue. That is 0 that are in that column. So that would be 0 out of 17, which we can just write as 0. There's a 0% chance. And then the last one, the probability they said no to the taco tongue and no to the evil eyebrow.
3 out of 17.
3 out of 17. Right, no to the taco tongue and no to the evil eyebrow. That's what those mean. So, okay. Okay, so when I look here, what's the probability that the person chosen at random is yes for the evil eyebrow? Yes for evil eyebrow. It is 12 over 17. What's the probability they said no to the evil eyebrow? 5 out of 17. What's the probability they said yes to the evil eyebrow or no to the evil eyebrow?
I put
So-
7.
This is a new word. Everything we've done so far has said, like when we've had compound probabilities, they said one and another. Right? When it says and. So when we see the word and, that's what we call a union. Okay, so the way we would write that, the probability of A union B, means we want to know the probability of A happening and B happening. I think I'm doing this backwards. Hold on.
I'm lost.
I'm doing it backwards. Give me just a second. So let's focus on or, because that's what we're looking at here. Probability of A or B happening. That's the one that's a union. When we see or, that's going to be a union. All that means is we want to find what's the probability of A happening, and we're going to add it to the probability of B happening. Because we need one thing or the other thing to happen. So again, this is or, we call a union. Think about what is, have you ever heard of people say, like marriage is a union of marriage? You ever heard of that? So what is a marriage? Where two people join together, become one. So that's why we're looking for an or, because or means it could be A, if they were part of A, or if they were part of B, now those probabilities are joined together. So when I look at this, what's the probability that they said yes to evil eyebrow? Yes to evil eyebrow. 12 out of 17. But because it's an or, we can add, what's the probability they said no to the evil eyebrow? 5 over 17. So what is 12 over 17 plus 5 over 17? 17 over 17, which is 1. Think about it like this. What's the probability if I pick one of you at random that you can do the evil eyebrow or you can't do the evil eyebrow?
17.
Every one of you fit into one of those categories, right? Because those two categories are mutually exclusive. They are separate from each other. So that's 100% chance that I choose someone that fits into those categories. Because it's both of them. That's both sides. That's like saying, what's probably I flip a coin and I get heads or tails?
You'll get one.
It's 100% chance I'm going to get one or the other. Heads or tails. Those are the only two possible outcomes. Same thing here. What's the probability you say yes to evil eyebrow or no to evil eyebrow? It's 100% chance. Which we can write as 1 as a decimal. So that was kind of the tricky one in that one. Let's look at 6. Suppose we randomly choose a student from class. Find the following probabilities. So what's the probability that they said yes to taco tongue?
14 out of 17.
What's the probability they said yes to the evil eyebrow?
12 out of 17.
And so now I'm looking for what's the probability that they said yes to the taco tongue or yes to the evil eyebrow?
16 out of 17.
Okay, how did you get 16 out of 17?
I just added this up.
Is it the opposite this time?
This doesn't make sense.
What do you mean?
It's so stupid.
So when you think about this one, are you guaranteed to fit into yes taco tongue or yes evil eyebrow? No. Were you guaranteed to fit into yes evil eyebrow or no evil eyebrow? Yes, because these were complements of each other. Right? The opposite of yes evil eyebrow is no evil eyebrow. So they're complements. But here, these are not complements to each other. Yes to taco tongue or yes to evil eyebrow. So this here, this is what we call mutually exclusive events. Exclusive. That means you had to fit into one category or the other. Okay, but here, this bottom one does not fit that category. These are two separate events. So here's what we have to do. Think about it on the Venn diagram. Let me draw it up here. That'll probably be easier. You guys might have to help me make it look like y'all's. What is what was this circle?
Yes.
Yeah, but what does it say?
Yes, taco tongue.
Yes, taco tongue. This one was 12. This is 0. So this one was
Yes.
yes.
Evil eyebrow. Yeah, evil eyebrow. Yeah. 0.
Right, that one was 0. And then we had 3 out here.
Correct.
So think about it like this. And this one. Where's everyone that can do the evil eyebrow? If they said yes to evil eyebrow, they are in this circle, right there in green. Do you follow that? That's everyone that says yes to evil eyebrow. Now, where's everyone that says no to evil eyebrow?
And purple.
Let's not use purple because I use purple for the drawing. So let's use black.
And black.
Where's everyone that said no to evil eyebrow?
On the other side of the circle. And black.
So did these people, did they say no to evil eyebrow?
Yes.
Yes.
They did.
Only 2 did, but the other.
Did these people say no to evil eyebrow?
They said yes.
Yes. So what is shaded in?
Everything around that circle.
Everything on the graph is either in green or it's in black. That's what makes those mutually exclusive events. They are not connected at all. All right, you see how that one's filled out? Now let's do the same with the other or statement that we have. So again, I got to fill this out. Sorry, can y'all tell I've never taught this before? This is new. I'm winging it as we go. So this is yes to taco tongue. And this is yes to evil eyebrow.
Just put evil.
Just put EE and TT.
What's here? 2, 12, 0, 3. Okay, so now, looking at this or, what's the probability they say yes to taco tongue? Where's the people that said yes to taco tongue? They are here. Right? Everybody in this circle said yes to taco tongue. Do we understand that? Even these 12 here said yes to taco tongue. Now, where's the people that say yes to evil eyebrow? They are in this circle.
Everything around it.
No, just inside this circle is yes to evil eyebrow. Including the part that I've already filled in black. So here, the blue and black meet each other. They overlap. You guys see that? Where here, did the green and black ever overlap? They were mutually exclusive. So when this happens, you have what's called an overcount. So here's what we have to do. What's the probability they said yes to taco tongue? That's the people that are in black. There were 14 out of 17. Or we're going to add. What's the ones that said yes to evil eyebrow?
0.
Nope. 12.
11.
These 12 said yes to evil eyebrow. So it's going to be plus 12 over 17. But some of those people got counted twice. Which ones got counted twice?
The people in the middle.
The ones in the middle. So we would need to subtract the 12 over 17. This was kind of a funny example because y'all have nobody here in this one. Right? But if there was some number here, it would get added to it. But that's the overlap. That's the part where they both are colored in. That's the part that I'm subtracting. So if I add 14 over 17 and 12 over 17, then I subtract 12 over 17, that's going to leave me with just 2 over 17. That means there are only two people that could do one or the other. They couldn't do both. They could only taco tongue or they could only evil eyebrow. And that would be these two people. Right? If there was a number here and here, this is anything but 0, those are the two that would get added together. Because this part's the overlap. I've counted it twice. Those people don't exist twice, but I counted them twice. All right, I told you that this was a little more challenging probability than yesterday.
I wasn't expecting it to, though. Will you put that bag up?
Have a great day, Mr. Cooks.
I didn't know that. We never get finished.
Sorry.